students really appreciate because many of them may have classes at this time. There's no perfect one time to do these sessions. So
No worries. Let me just see if how do I share a screen. I'll start the presentation then. Incoming. Share screen. How do I share my screen?
there should be kind of third button.
Oh yeah, here. So yeah.
By the way, when you guys are talking, also good to unmute and save video if possible. I guess if you join from the web, you may not be able to share slide and video, but other times you can. So that's the restriction of Teams, I guess. So yeah, we see the slides. Yes.
Perfect. Great. So thank you, everybody. We realized, the first of all, our first meeting where we were talking about how to do an AI startup and how to build a startup from scratch is a real story that we started out with. It's fortunately also a startup that is very close to you guys. It's in Houston. We haven't still decided the location. Probably it can turn out to be Dallas, that we prefer that as a location. So in the first sort of conversation, you all got to know a little bit about, what are the challenges, how to come up with a business model, how to develop a solution, and the problems that you run into when you're typically doing a startup. It all starts with a basic idea. There's a founder, but there's no technical team. You start looking for teams, and then you come together, and then start realizing, well, the data is there. And essentially, all that thing that you run into actually running a startup, the physical aspects of a startup, meaning finding people, is a different problem altogether. And what we're going to be doing in this talk today is give you guys a bit of perspective on what is the technical challenge that you run into when you're doing a startup. So just for the sake of just to be clear, what we will be talking about in this MLOps, which actually is DevOps plus all the machine learning operations that you do. So it's kind of a very popular term lately called MLOps. We're actually going to be taking you into a journey of this. So this is what we're going to be talking about. And specifically, we're going to be talking about the CI/CD pipeline, how to build these ML elements, and then deployment strategies. Do you want to do it on containers? Do you want to do it on raw iron, virtual machines, cloud computing environments, and how to scale these operations? This is what we're going to be talking about. This part on the left is doing AI. I'll just kind of write it here, sort of doing AI. And if you have been past students of mine, together with Professor Jay, we have been doing a bunch of workshops, sort of giving you really super hardcore real world AI experience. And doing AI is another session we have on the 3rd of September, same time. And we're hoping that you guys can make it there as well. And here we'll have two of our bright AI researchers, both from IIT Kharagpur, they're PhD candidates, and they have built a data set. They did a ton of training on AI models, and eventually experimentation, data exploration. All these things will be on the 3rd of September. All right. So going back to what are we going to be talking about today? We're going to be specifically talking about actually all these aspects, including these as well. Obviously, MLOps is a massive sort of, ecosystem, or ecosystem is kind of like a life cycle. And one thing cannot do without the other. So if you do not have, efficient and working AI models, it makes no sense to do MLOps because you're just doing a bunch of DevOps. So if you have models, you need to make sure that the models are fresh, they're not stale, you don't have data decay, you don't have a model drift. And all these terms you will get familiar as you start learning about what MLOps is. There are many, many tools in the market, a couple of hundred tools already in MLOps. So specifically, if you look at just, if you want to do model registry, there is a tool out there, model registry. There's also a company called Databricks. I'm sure you've heard of that company. And Databricks is a company that actually does a lot of MLOps. It doesn't cover everything. They do have a tool called MLflow. And there, they tend to cover a lot of aspects of it. It's also an open source free tool that they have released, so you can use that and play around and actually do all these things of registering your model. The best model should be deployed and not the ones that you've been experimenting with. They should keep going back to this. And then you start adding explainability, interpretation. How do I reproduce? So you need to test that. Adding security to your models, for instance, privacy and all these other aspects need to be also added to it. Risk mitigation, bias, fairness of the model, etc. So there are a bunch of tools out there also to do that. Then you have continuous integration, continuous deployment, CI/CD pipeline. Suhas is going to take you into that sort of journey. And then building elements. What I mean by building elements is all the design elements. So the design, just like design patterns, if you've done software, and if you understand a little bit of software engineering, so it's essentially actually design patterns or ML, I'm just calling them ML elements, design elements. And building those will actually make your software platform robust. And then you start talking about deployment strategies. How do I deploy it? Do I, put it on container or just purchase a lot of hardware machines, use virtual machines, and then eventually scale this AI deployment by adding more nodes to the servers. And then once you have deployed your MLOps, essentially deployed MLOps or deployed your AI models into production, then you start looking at the performance issues. Is my model getting stale? How do I make sure the model drift, the model shift is happening? And how do I sort of ensure that my models are continuously being trained for new data and new features and new modalities that are coming into my model? And this is where you start actually going back to your AI and ML team or the researchers to say, guys, we need to actually refine the model because there is some data shift. Or there are different new features being added to the model. And then you maintain your model logs here, your ground truths, and your dev and experimental data. And essentially, you have performance data. And this is the feedback loop that keeps going back into your AI ecosystem. This is how you complete, actually, your MLOps lifecycle. So this is just giving you guys a bit of introduction. Let me just go back to Teams. And hopefully this gives you folks a bit of idea of what MLOps essentially is. So let me just stop the presentation, put my camera on again so you guys can see me. And essentially what we're going to be doing now is I'll just give you a bit of an agenda so you have a bit of a perspective of what am I going to be learning here and how does this sort of flow looks like. So in the next talk, Suhas is going to be sort of giving you a bit of a perspective of the CI/CD, so how sort of architectural choices that needed to be made in order to make sure that this AI models that you have trained with great care are going to be deployed with equal great care into a production environment. So there's a ton of environments like Amazon, infrastructure as a service, as it's called, AWS, Azure, Microsoft Azure, Google Cloud, Alibaba, and there's a bunch of other sort of cloud computing platforms. Or you have a platform as a service platforms as well, like Heroku, Streamlit, Netlify, you name it. There's a bunch of stuff out there. Or taking some stuff and creating a hybrid sort of a solution. Then I don't want to train everything in the cloud because it costs a lot of money. I want to train in my privacy. That's how we do it in Deepkapha Labs. Is we have our own supercomputer right now. That gives us super compute capacity to train massive data sets, of hundreds of gigabytes, stuff like OpenAI has done. We're able to do that as well. And then, ship those trained models and put them into production in a cloud computing environment. Just like how, for instance, Netflix does. It's a much bigger company, obviously. And they do sort of streaming, batch processing is happening, streaming, all that stuff is happening. But we're not going to go into details today. So this is how MLOps should look like. The machine learning operations is all about building great models, taking these into productions with great care, monitoring these models, providing a feedback loop in order to make sure that things are continuously working in tandem. And so this, I'll sort of wrap it up in the end. So this is what Suhas is going to be talking about. So once he's completed talking about the CI/CD, then we have Shivam, who's going to take you into front-end engineering, so software engineering, on how we build this wonderful first application already for this startup in Houston. And he's going to give you a bit of a walkthrough. I'll be around sort of helping you, supporting you guys. And then finally, David Allen, who is a student at UTD Dallas, has been working with us for over a year. He's going to be talking about another software development of a different startup that is Live AI, with which we're developing some awesome tools. He's going to be taking you into this journey of how what kind of challenges he ran into to develop the software. So once again, summarizing, Suhas will talk about how to deploy these models and architectural design choices. Shivam is going to talk about the software, the front-end engineering for this application of this energy startup that we have in Houston. And David is going to talk about another software development best practices, in which how he's developed this software for Live AI, which is our educational startup. So with that, I want to give it away to Suhas. Suhas, take it away. Feel free to sort of open up your presentation. I believe you should be able to share. And I'll be here at the back end, the background, supporting you guys with all the questions you may have. And please keep asking questions, by the way. I will make sure that I will note down these questions. You have your, you see this blob here. So you can chat, you can say hi to each other, and also pose your questions. And hopefully, once we're done talking, probably I'll ask Suhas to already answer those questions. Or if you have any questions to any of us, we'll be happy to kind of answer these. Go ahead, Suhas.
Thank you. Can you hear me okay, Tarry? Maybe you can confirm on behalf of everyone. You're on mute. I'm assuming you said yes.
I can. Sorry, yes.
Yeah. No problem. Okay, I've shared my screen. You should also be able to see my presentation. I can see it on my other machine. So here's the overview of what I'd like to talk about. Most of it, which Tarry already covered. What I've really done here is use the DevOps and the MLOPs practice that we want to do for PETI, which is you spoke to Fred yesterday, and you pretty much understand what we are building. One of the things that my role in that project particularly is helping out with the architecture, laying down some of the guidelines of how we can develop software in a more effective, reusable way. Now, some of the choices that I've made here obviously has come from tried and tested methods. Just as a disclaimer, none of these architectural choices are to be imposed in any way. Obviously, there's always better tools. There's always better pipelines that you can develop. This pipeline particularly is what I find interesting, because the focus of this pipeline really is to get started effectively and quickly without compromising on the quality of how we write code. Because one of the things that I've observed in early stage startups is that they subconsciously develop a mindset of writing code in a monolithic fashion, where you just probably have one entire Flask server with, I don't know, 1 million endpoints that are just doing the core functions of your business. Now, once they scale and once they've got better engineers and architects, they spend quite a lot of time trying to break down a larger algorithm or a larger process into different sub-processes, which usually is really time consuming. So hopefully you can find this this architectural choice a little more effective in your own startups or in your own ideas. Otherwise, if you're just working on a project, you're free to actually use any of these tools too, because most of these tools and recommendations are either free to use. You don't really have to pay anything. Obviously not AWS in a general sense, but I'll also try to cover a little bit more on pricing, because that's really important. Cloud, unlike how it was 15 years ago, it's quite cheap and affordable right now. So if I forget to talk about pricing, feel free to ask specific questions if you can use these tools as individuals. Moving on. So just want to cover up what DevOps is about before we jump into machine learning operations. The quickest way that I like to describe DevOps is essentially integrating a development practice of your team, front end, back end, whatever, into the operations of the organization. This essentially is effective because the way you look at an organization, you've got your product people that essentially speak product and process and structure, and developers essentially just care about writing code. Now, the way if you look at writing software, the developer's job sort of does not end and in de-risking a particular algorithm or a particular piece of code. The developer now has to sit down and make sure that the code propagates to a more to a different environment, make sure that it's supported at scale. So the role of the developer really is in an organization is drastically changed in a startup or otherwise really. So when you look at the history of writing code, right? Now you've got this structure where you've got to break down your problem, discuss it with stakeholders, and essentially build a smaller version of it, which sometimes we call as a mock version, or essentially that'll sort of define what the request and the response or the input and the output of a particular algorithm is, and doesn't really work on the major algorithm itself. And then you go on to defining the intricacies of how a particular algorithm works. And then you do an integration, and then you ship and you deploy, and then that goes to an internal team and then to an external. So this history of building things in now is a little more refined in a way where you've got things like environment segregation. So you've got different environments where you've got development environments, you've got production environments. And I just want to go over what these essentially mean, because as an early stage startup, if you are maintaining a single environment where you've got clients, you're doing demos, and you're also building, what could be the potential mishap of that particular practice? I mean, obviously, when I was building my first startup, one of the things that I did is just maintain one environment, because I never thought, okay, why would we need a second one? And that actually led to, hilariously, the survey going down in one of our investor pitches. And we had trouble explaining as to why we didn't have two environments. Looking back, obviously, that was a horrible decision to have made. At the time, we were all young guys, and we just wanted to build something and show people. So there is a good amount of planning that you have to do before you write code, and that's essentially what DevOps is. It's to define and to commit to a plan of segregation of a pipeline, which helps you create, plan, and execute, and most importantly, test what you write. So going ahead, this is what I think about when I want to summarize what DevOps can help or what DevOps does. As I covered earlier, it's environment progression. How do you have code working in an assured way for clients, or even just for demos, or for your developers, in a way where you've got a safe, secure environment for developers to update, test their code, in a way where if the environment goes down, there's effectively no business risk. You don't lose money, you don't lose customers. Compared to a production environment where a possible downtime could lead to some sort of an undesirable effect. One of the funny things that I usually noticed early stage startup do is fixing bugs and fixing errors on the go, when a customer comes in and says something isn't working, and then the ticket sort of gets a amber rating, which essentially means that this has to be fixed effectively immediately. And a poor developer gets allocated to it, and they keep working on it, they fix it and they push it, and it goes to the environment. But one of the things that sort of gets overlooked is, does it work well with the existing code? Does it work well in the environment where the client is working? So does it actually fix the issue? In a lot of ways, what the client reported and what developers actually fix, there's sometimes a mismatch, which can be avoided. So when I'm talking about environment progressions, we are also going to talk about something called as a UAT, which is something called as a user acceptance testing. which essentially is a simulation of a couple of users or a closed group of users, which test out the product from a non-technical sense, because as developers, as product owners, we're completely biased towards how we use interfaces. And this is a study that is pretty open. I'll make sure to drop a link later. Is when you're testing out your interfaces because you've built them, you find them to be effective, you find them to communicate what you would want them to communicate. Oftentimes when actual people use it, when real people use it, it's not always the case. So you might just be fixing something to make it even more esoteric. So feature switches, this is particularly really important for early stage startups. That's only because of the fact that one of the fun and also the scary thing is about building a startup is you don't know what you're building, or you don't know how you're going to build it. The features specifically don't come to you in any written way as a requirement, as in today you might just be building a feature to do X, and tomorrow it can just drastically change to Y. And the challenge really here is how do you make that transition from changing the output of a particular feature. It could be visual through an interface, or it could just be an API, or it could be something as like, adding a couple of more features for your model, and maybe you want to switch to using another model altogether. The requirements are just very volatile in an early stage startup or in a startup generally. So having that capability to hot swap features almost immediately in a way where it works, it can be served to clients or to whoever the end user is super important. This is a nightmare if you don't have an effective pipeline. This effectively means that you've got to have dedicated people working long hours trying to make sure that the feature swap does not affect multiple code bases or servers or worst yet databases. It's known that whenever you have feature switches, databases usually, have some sort of a compatibility problem. It could essentially be about how you're reading data, how you're writing data, and effective testing should essentially also consider how databases are set up in multiple environments and to facilitate for feature switches. Frequent delivery, that's actually pretty impressive in a good CI/CD pipeline. It's because it's sort of, when you think of a sprint, by definition, a sprint, in my definition at least, sprints are effective only because of the fact that they have a planning, design, development, and delivery cycle in a fixed amount of time. If your features aren't too long, usually this is a week. Otherwise, this could be any period of time. As a matter of fact, you can sort of set that when you're writing code. The reason why frequent delivery is why that's relevant in developing software at these times is because we inherently have somehow become very impatient. When we request for features or when we want to sort of see something work. The most obvious things on the internet that takes complex engineering, when it doesn't work, we get annoyed. We're like, this is just a login form. Why does it not work? This is just a sign up form. Why does it not work? I'm just trying to book a cab. Why does it not work? And somehow the bar towards delivering software is set so high that it's just supposed to work when it's supposed to work. In a lot of ways, that's good because you've got like excellent developers writing really good code. But the problem is, when do you deliver it? Do you usually finish do you usually finish an entire feature or an epic, as you call it in Jira and project management terms, and just deliver it and drop it on the user like it's like some cool Nike shoes? No, really, you shouldn't do that. It's really breaking down code into weekly deliverables, even if it's into your internal users or your beta users or your alpha users, to see and measure acceptance. And while doing this, you encourage a new level of testability like A/B testing. It's about how effective is the feature or your pipeline that you're essentially measuring. So this, and again, just to refer back to how software was developed before, and I'm just going to take a use case of Axis Bank, which is a bank provider in India, pretty privately held, but pretty substantial, pretty big guys here. The bank essentially has an excellent application on iOS and on Android. And they decided to, and they've got a technology provider that essentially has that develops the software. One of the things that they want to do is improve their credit card system of how they wanted to improve the UI of it. So instead of rolling out, the deliverables and interfaces patches in a weekly or like a sensible manner, one of the things that they did is they introduced the platform overnight, the revamped platform, and the next day it went down, which meant that people couldn't use their credit cards for a week and also couldn't pay bills. It was an entire mess. It's the reason why I'm saying this is not a lot of people, even if they're too big to fail, like Axis Bank, they can't get it right if you don't understand the effectiveness of a proper development and delivery cycle. I'm just going to skim through the rest of them. CI/CD also even in MLOPs helps us automate a lot of tasks. As I said, sprints, shorter development cycles. You've got room for rapid experimentation in a way where you can ask people to, innovate on a couple of features, specifically in models. And when you're building one, when you're training models, you can have different teams sort of build different models with maybe different features. And with the proper CI/CD pipeline, hot swapping them to see what works in real data would be a lot more easier.
I just wanted to very quickly check. I'm not able to see this your presentation. Is anyone else able to see that? It could be my issue. Fred, can you see Suhas?
Visible to me, Tarry. Yeah.
All right, you guys can see it. Okay, go ahead. No
but
worries.
it's on like TLDR slide still, or have you changed the slides? Suhas, just to confirm.
No, that's the same thing.
That's the same thing. Yes.
All right, go ahead. It's just my issue then. Go ahead.
Moving to the next slide now is did I move to the next one? Because I see here that I've moved and on Teams it hasn't reflected. Can someone confirm?
I hope no, not on my side, Suhas.
Right. Let me quickly try to reshare. Oh, I see that it's working now.
Yeah.
Yes, it's working now.
Yes, use cases. Perfect. So now you're getting into the use case of our project, right? So yes.
Yeah.
All right, perfect. Go ahead.
Yeah, I apologize for my handwriting. I just wrote this when I had the idea for how we should be designed, and I'll just walk you through the idea of what we are doing here. So Shioma is going to get into the specifics of how the interface is, etc. Now, I just want to talk more on the architecture side. So high level, we've got a use case where people are coming in, uploading files, and the file goes to, we call it a log actually, so I'm going to refer it as a log. A log goes to a server. Logs essentially go through a ML process of digitization. So you can essentially think of this as a raw CSV file, a PNG or a JPEG image that is being digitized. So maybe you can even think of it as sort of like an OCR process, except for the fact that they're not characters, they're just squiggly lines on a piece of paper, and they have to be digitized. So obviously, as startups, you don't want to do this commitment towards a single cloud provider because everybody's got their pros and cons. AWS, excellent to start off with, but if you lock in, you're going to rack up a lot of hefty bills. GCP, a little harder to get started with, but has a lot of more discounts and a lot of friendlier to startups. So I'm going to go over what we were thinking about when we designed this. So one of the things that we wanted to do is to write code in a way where it's reusable. So we design things as a microservice. If you don't know what a microservice is, essentially, if you've heard of this, the function singularity principle, essentially, which says that a function is only supposed to do one thing. So a microservice, you can think of it as the same way, except for the fact that it just does one service. So you've got maybe login as a service, registration would be another service, upload would be a service. So there's proper segregation. So each one of these blocks here are allocated their own hardware requirements. And one of the things about these cloud providers is they allow you, based on traffic and based on usage and based on how your code is written, by measuring space and time complexity, to configure how much of space these cloud microservices essentially take up. So in AWS, I'm going to drop in links about these specific names later on so you can look it up. We use something called as Lambda. Lambda is not to be confused with the Python Lambda function. Lambda essentially is an AWS service that lets you write Python or Node microservices. It's a serverless function essentially, and essentially means that you don't need a physical, you don't need a server, you don't need an EC2 server. And I don't want to really talk about the uses or disadvantage of a EC2 server. Except for the fact that, I just want to bring up the cost option here of how Lambda services or microservices here are effectively a lot more cheaper, only because of the fact that they run when somebody uses it. So if you develop a microservice on an EC2 container, you are being charged when this server runs, which is effectively till you stop the server. On Lambda, however, you can write your code and it sits on a serverless function, and you only pay for what you use or what your customers use. So if you've got a function that is invoked 100,000 times, you pay that much into price per invocation. And obviously you have some free tier here I think it's around 100,000 invocations, which is free. So it's a lot more cost effective. And to us, it made sense because we don't want to pay for something that we don't know people are going to use. And tomorrow, when we know for a fact that something is important and something is a little more expensive, we can migrate to an EC2 container. So microservices were designed, we've got a couple of login services, which essentially do exactly what I said as a microservice. And we've got something interesting called as layers. And this is, again, a very AWS specific term. Layers, you can think of it as libraries that we've written. So we've essentially written these Python classes that communicate with infrastructures like, S3, which is a storage service, or KMS or IAM or any other AWS policy. Now, the reason why this is interesting is this really helps developers write specific code for that particular microservice. And so you don't have to have two developers writing the same code to connect to an S3 bucket, or to read or write data from an S3 bucket. So Layers has generic code and microservices has specific code. In a way where if somebody wants to connect to an S3 bucket, they import it from Layers and they essentially, they're good to go. In other organizations where I've pretty much defined the same architecture, we found out that investing time into writing generic layers is effectively solve time as you scale. So if you've got a couple of developers today and you want to scale effectively, can be converted into a particular layer and you can host it. As I said, I'll drop in tutorials from AWS, which are very well written, to how to use Lambda layers, how to use microservices, and where you can write your own APIs and you can deploy it. These sort of get converted into APIs using API Gateway, which is again a service using AWS, which help you host and deploy your APIs. This is a lot more cheaper than running your own Flask framework or your Django framework on an EC2 container, because at the end of the day, you don't have to do hard things like load balancing, etc. Quickly, in the interest of time, I'm going to move on to the GCP side. So this is Lambda layers and AWS. And GCP, we do a lot of data engineering where we have data science teams over here, iterate things through Jupyter notebooks. And we have a couple of services on GCP, which are just about model building and model hosting and model management. And Tarry talks a lot about these services specifically. And all of these topics are, an hour's conversation themselves: data cleaning, feature engineering, high parameter tuning, model serving, monitoring, model management. And there are so many services you can use. But as an early stage startup, we just thought we'll just put everything in GCP and we'll just monitor and manage things here. And there's, I think, Vertex.ai is a service that GCP uses, which is pretty effective. So this is the high level architecture of what services we want to use. I'm going to use the same template to further talk about how the CI/CD pipeline for regular engineering and also the data science is effectively built. as we go ahead. And just a quick thing before we go forward. The message queue perhaps is the most important one, because this makes sure that any request that is sent from this server over here does not get lost when we go to the server over here. So that's the role of the message queue. Now, I want to quickly talk about how people write code. I hope that a lot of people here have heard of GitHub and have used GitHub at least once. If you haven't, you're missing out on a lot. It's an excellent version control platform that you can use. Now, one of the things in GitHub is GitHub Actions. GitHub Actions is particularly really cool, only because of the fact that it allows what should happen once code is pushed. If you merge or write code into and commit it to GitHub, GitHub Actions automatically allow you to trigger a particular job. And they've got a nice marketplace where you can download or just install some of the plugins that people have written. And I just want to show you how we've integrated our own GitHub Actions. This particular, moving on to the next one. Yeah, this particular slide talks to you about how GitHub Actions and how people have been writing pipelines since Jenkins, which is really old. One of the CI/CD pipelines that were written back in the day and still being adopted. By the way, it's not to say that nobody uses it. So the thing about GitHub pipeline is it sort of works as Lego, right? It's block-wise, and your code, you can think of it as, building blocks, and it can sort of be pushed wherever you want and to any environment that you want, AWS, GCP, in a way where you don't really have to write a lot of code, because there's already existing boilerplate templates that you can use to write code. There's a really interesting article that said stop rewriting pipelines. There's a link over here in this presentation, and I'll include it here. It's a wonderful read, which talks about why CI/CD pipelines have to be a little more effective with respect to how they should stop getting people to write most of the CI/CD code, which we will discuss in a bit. Now, back to GitHub Actions. And these are some of the events that GitHub allows you to take control of. And I've summarized this. There's obviously a lot more. You can find it in the source here. So I'm just going to go through a couple of use cases. Imagine if somebody created or pushed code, and you want to, the minute they push it, you want to run unit tests because you want to see if their code is good enough or it breaks the system. You can use GitHub Actions to do that. You can set up a unit testing cycle or an integration testing cycle, which is fairly automated. And once somebody raises a PR, you can essentially have the automated report, which details how the code is working in a particular environment, and only merge if the code is working. And if it's not, you can just say, no, it can't be merged. And if somebody raises an issue, and this is a really interesting thing, because if somebody reports an issue, you might want to notify people. You might want to trigger a pipeline to, I don't know, test it out or make a report yourself. You can do this with GitHub pipelines. Creating a repository or creating files. This is really cool because in one of the presentations that we did with Tarry and a couple of other folks for a workshop, is that I demonstrated how to use GitHub Actions to use it as a system to collect data, to ingest data. One of the things that I like to think about is how can we rethink how ingest pipelines are done. You could essentially have a complex airflow system which takes in data and have a graph directed a graph which redirects it to a cleaning script, and then that goes to a scheduled job which saves it in a file as a JSON, or you can hack existing tools to do the same thing. In this particular use case, I don't have a demo in this, again, for the interest of time, but I can share the code with you. The pipeline, the GitHub Actions was configured in a way to pull in data every 15 minutes and save data in a JSON file in a way where a bot was sort of committing data back to the repository. So every 15 minutes, I just had a script on GitHub that would get invoked, and it was written on Python. So it would go ahead and get the API, collect the data, write the data back to GitHub as a commit. So in a way, this repository was just growing with more information. It's not a best practice if you want to keep gathering data, because GitHub has a restriction on how much data you can store in a repository. But if you're just interested to get the latest data and you don't really want to use any servers and you just want to run it for free, you can do it on GitHub Actions. Like, this didn't cost me any money to do, and this can run effectively without any problems. All provided GitHub Actions doesn't go down, which sometimes it does. So you might want to keep an eye out for that. So some of the use cases, again, GitHub Actions, you can write your workflows, you can design APIs, you can build, you can connect it to really cool applications which are not on GitHub, like Jira. You can connect it to other tools that you can use for project management. Back to our use case, the project that I was talking about. How do we use GitHub
By the way,
Actions?
all these, what Suhas is explaining right now is a real world AI project. These are not theoretical sort of, we obviously we gave you a bit of a high level perspective. So whatever that we are showing right now is being built, and the CEO who you spoke to, Fred, he's also in this call, and he can also you can have a conversation with us later. So this is sort of real world building that we are doing. Go ahead, Suhas.
Yeah, that's correct. So if you recall, the last time we were talking about cloud providers, AWS, and okay, Fatima, you've got a message.
I'll take those questions later for you. Go ahead.
No problem. Thanks, Tarry.
Fatima.
So yeah, back to the cloud functions. I mean the cloud providers from the previous couple of slides I was talking about. Now you might just be wondering, so how does my code actually go to AWS Lambda? How does my code actually go there? Does somebody, and finally, just to elaborate for 3 seconds, I worked in an organization where there was a person who was appointed and hired really to take code from GitHub and install it onto servers. And these pipelines literally automate that. The reason why this is funny to me is because these practices are still persistent in most organizations. And if you just ask yourself the question, how can something be built better? The answers tremendously sometimes can blow your mind away in a way where it can actually automate people's jobs. Because we're in the industry of doing that. And you can either automate to make people's lives better, or you can just automate to make people more efficient. So at the end of the day, I'm just going on a rant here, apologize. So in our use case, we obviously work with a couple of developers that maintain their own branches. So let's just say, somebody's working on this branch and somebody's working on this branch, and they're working on their own features. So when they run their own unit tests, when they run their own tests and they're happy with it, maybe this branch gets merged to this branch on GitHub. So we've got 2 standard branches. So first branch is called master. The second branch is called dev. And these are the branches that I have created. The idea really is that whenever code gets pushed to dev, it should update the development environment. And whenever the code gets pushed to production, that should update the production environment. It's simple, right? And it works. So the way we essentially do it is through PRs. Whenever we have a pull request of all of this code onto dev, we define an action, which is, again, remember, a GitHub action to take all of the code and update that particular Lambda. I'll get into the specifics of how, but I just wanted to show you and talk to you about the trigger point. Now, let's assume that the dev environment gets updated, nothing breaks, everybody is happy, features are working, and then we come back and we manually update the production branch by just creating another PR. The cool thing about this is, if you are running unit tests, integration tests, or if you're just running APIs, or whatever is specifically use cases, there are a fair amount of tools that you can use that can help you with testing. So this practice specifically really makes sure the emphasis on testing. And one of the things that I usually like to have is locking branches, which is usually not a good thing to have in an organization of where you have less amount of people. But locking branches really make sure that your nothing gets accidentally committed to production, or nothing goes by without the stakeholders approving. Some of the things that we've done obviously is to update code base, which I've talked about. Database updates, which aren't really code, might just be one-off functions that you want to run. but they can be scheduled and they can essentially run using the same process. So there are a couple of database versioning scripts that you can run as actions. And you can use GitHub for the same thing, because one of the important things that you've got to realize is database operations usually get forgotten. So you've had this environment where you create a database, you insert values, you know, make all of these permission changes, and tomorrow if you want to launch another environment with the same setup, and you're like, I don't remember what I did with this database. Obviously, you know, you can't save commands on a TXT file or something. So there are tools that where you can sort of save database operations and run them as different files, and we do that. But in this particular use case, we use Firestore to maintain a database, so we don't really have this present for this particular problem. Scheduling jobs, very important, very interesting. Essentially, if you're, especially if you're ingesting data from an external source, again, you can have the same setup here. And the lovely thing about this entire setup is it's extremely cloud agnostic. So if you prefer Azure over AWS, or if you just care too much about GCP, doesn't matter. You can use the same thing. Or even if you have your own server, you can still use the same pipelines to do the things that I'm talking about. So code progression essentially is how we do from GitHub to whatever cloud provider that you want. Works effectively. Two different branches that we use, two action files to recap. One action file takes all the code, deploys it to production. One action file takes all the code, deploys it to development. And that's essentially where we maintain code, different stakeholders, make sure nothing is going wrong. Everything under one repository or one microservice. That's how we do it. Moving on to serverless, which is one of the things that I talked about earlier. I should have reordered this. This should have probably come a little earlier. But anyway, serverless is essentially the platform that we're using to run these jobs and to monitor these jobs. So this is a really confusing term, because serverless can be understood as the computing serverless, like the Lambda serverless that I spoke about. But this is actually serverless.com. If you can see here, this is a service. So serverless is a place where you can design, develop, deploy, and maintain these the CI/CD pipelines, and also monitor them. So serverless works with, and it's free to use for a smaller team, and it essentially insists that you write your pipelines in like YAML, where you talk about what cloud provider that you want to use, or you want to execute shell scripts, or you want to do whatever that you essentially want to do. So it really helps you define your workflow or your development cycle. YAML, if you don't know what YAML is, you can just think of it as a structure like JSON that dictates like what should happen when something is executed. Serverless is relatively easy for you to catch on because it's written in usually plain language, and there are a lot of support from the community on what sort of libraries that you would want to use. And the cool thing about serverless is you can configure it to run with GitHub Actions. So some of the GitHub actions that you may see in the marketplace off the bat may be a little simple. And if you're the kind that has a very specific use case in a way where you want to maybe take a couple of files, unzip them, train a model, or to trigger a pipeline, ingest pipeline, you can configure all of that on serverless. I'm still personally learning a lot about serverless, although I've probably used it for the last couple of months to write pipelines that dump code to AWS. So it's definitely worth looking at. So moving on, and this is the high level a picture of how it works. I see again that my presentation has frozen. So I'm going to do this because for some reason that works. This is the code orchestration and the progression for PyTI. So you have GitHub. We use serverless to push models and to push code to AWS, which has two different environments: AWS for development, AWS for production. And Shivam is going to talk specifically about the front end part of both of these things. So there's a clear segregation. This is prod. This is, oh, sorry, that was dev. This is dev and this is prod. So even for GCP, we use the same pipelines, we use the same providers, and we use the same actions. And the cool thing about it is, once it's essentially deployed, you can use it wherever you want. So I understand I'm not getting into the specifics of how to write these pipelines, because covering them would actually take a couple of will take a good amount of time. But I can a couple of tutorials to explain how it's essentially done. That's pretty much the end of my presentation. If you've got any specific questions, I'm happy to answer.
Let me take the questions, then I'll try to see. Okay, Fatima had a question. What message queue is used for this project? I believe that's what your question is, I hope, Fatima. And also both AWS GCP was used in your solution?
Yeah. So
that's the question.
okay. So yes, we do use AWS and GCP. AWS, we find that the the model making, I'm forgetting the name of this, SageMaker. Yeah, SageMaker is really expensive. So GCP, however, the cloud compute costs for running GCP is a little lower. One of the things that we were looking about is like running these expensive ML functions as cloud run functions on GCP. And obviously, when you're raising funds or otherwise, it's always excellent to have at least some of your core code on two different cloud providers. So for this, we deliberately use AWS for just the standard engineering practices of writing APIs. They're a lot quicker to do that. GCP for the model making. I'm going to go back to the GCP section, which talks about what we do there. Yeah. So model management, monitoring, that essentially is going to be done on GCP. AWS, again, microservices, etc. We haven't finalized on a message queue yet. We have identified that we need a message queue. So off the top of our experimentation, obviously we don't want to write a message queue. We could use something like SQS, which is essentially Amazon's answer to message queues, a queue as a service. The reason why we want to use a service rather than developing something ourselves is because we want to make sure that messages don't get dropped. Messages here could essentially be something as important as a file upload or something as important as a user's request. Dropping it effectively means that you've forgotten what the user asked for, which can be pretty embarrassing in this situation. So SQS is pretty effective. They almost never drop messages, and they've got a good configuration on how you can set them up, message size, and also force you to have the best practices for the same. If you want to talk open source, there's Django Celery, which is an effective message queue, which you can set up and save some of the messages that you want. And there are RabbitMQ messages and message queues and other ones, but they've got some problems in production. If you want to look for a message queue in a way where you don't want to focus on infrastructure setup, I personally recommend SQS. Very easy to set up. You can just think of it as a push-pull sort of a system. You can also integrate well into scheduling jobs with SQS. So we're most likely to use SQS for this particular solution. I hope that answers your question. If it doesn't, you can let me know. I can try better to answer.
Yeah, it did answer. Thank you so much.
Very good. Awesome. In the interest of time, I know we spent some really valuable, actually wonderful 30 minutes, and I totally enjoyed it. Every time I talk to Suhas, we've been a little bit sort of, we're not sort of trying to show off and a bit modest. Suhas is himself an entrepreneur. He's working with us on a bunch of startup ideas. But as an entrepreneur who's worked on this whole life cycle of running a startup, building, learning from mistakes, eventually exiting a startup in essence, really sort of relinquishing its value to the buyer, he's seen everything, and which is great. Suhas is a very young age, so it's very fascinating to see that this technology is sort of evolving so fast, and I'm super proud to have Suhas kind of again explain, and it's a joy to actually listen to it, and I hope you guys had a sort of useful understanding of the architectural decisions, deciding on when to build versus when to buy, or I would say build versus buy, or build versus use an existing prepared sort of pipelines, tools, APIs, best practices which are actually out there, and GCP, Amazon, and Azure, Microsoft Azure also, they provide their own sort of jargon, all these names they have. So they have all these things. Wonderful. Suhas, thank you. Now we're going to move into the next few minutes. It's not going to take long now. So I know you've been very patient listening to this. The next couple of minutes, I'll have Shivam. He'll use the presentation to show the front end. So essentially all these things which Suhas shared with you about building a login, creating all these functions, eventually presenting and representing these in visual, sort of great user experience and user interface, is where Suhas is going to take you to a few minutes of a journey. It'll be a brief sort of presentation, and then we'll have David. He's going to talk about the other sort of presentation where he's developed another app, a wonderful app, actually, for another startup of ours. So Shivam, go ahead. I hope you have all the the connections working and everything is well for you. I know you're not well, so I'll be here supporting you.
Yes, Terry, all good from my side. So basically, given the time constraint, I'll keep my things short. So I'll start with giving about my brief. Basically, I have been working
very
with
quick introduction.
very quick introduction.
Well, yeah.
I've been working with deepkapha for a year now. So working in the startup, we have to like swap roles very frequently. In the starting, I have worked as an ML engineer, as a pure ML engineer. Then for the current project, I have shifted myself to software development. So this has been like a great learning journey for me, graduating like 1 year ago only. So that was a brief about me. I'll share my screen to give you a presentation about the application that we developed. The screen is visible. Can you please confirm once? You should be able to see a screenshot of the application.
Yes.
So basically, I'll walk you through the important and the most fun part of our application. This is the main dashboard. And then after this, explaining the main working of the application, I'll show you a demo video of the whole working application. So basically, there are 3 blocks you can see here. The first one is to visualize the scan log. The second is to visualize the digitized log. And the third is to post-process log. So the first block is simply to upload the raw log that is generated at the fields, the raw graphs in simple terms. Then these logs gets uploaded to AWS S3 bucket via the upload microservice that Suhas explained. And in the backend, it is generating a secured upload URL, and it is mainly open for like 2 to 3 minutes time window. If it is not has been uploaded in that time window, then the URL gets cancelled, and you again have to upload the file. So it is more like a secured way to upload it. Once the upload is completed to the S3 bucket, the Firestore function, cloud function is called, that sends this URL to the another microservice that is basically the trained model, ML model, that processes the digitization process of this raw log. So then once the raw log is digitized from backend, it sends an event to the front-end application via the Firestore function again. So in the second panel, you can see the digitized log here. So basically, it is more of it eases the process of the user. Then in the third panel, there is a post-process log. Post-process is simply like reducing the noise from the digitized log. Given that we don't have knowledge about the well logs, we can't see much difference here. But if we ask Fred to look into this, he can certainly identify the noise in the two graphs. So basically, these are the three functions. Now, if we talk about the like the stack, we are using React.js for the front end part, and Firestore mainly for the authentication and the cloud functions and the database also. So Firestore makes our life easier in a lot of ways, like for the authenticating the users, and for the cloud function, as I mentioned. And say, if I say like the front end, this might seem a very simple application as of now, but to be honest, if our goal should be like to simplify the customer's work, and that is what we are trying to do. No fuzzy menus, no fuzzy lot of choices to take. You just upload the log here and you get the digitized log. That is what a customer wants. Now I'll show you the demo video. I'll be playing that video in the backend. Just give me a moment.
So when Shivam is talking about logs, last Monday, Fred, who is also here in the call, he explained about the well logs. They are like almost like they are like seismic data. So essentially, you see log files with a lot of zigzags, and essentially it was a tremendous effort to digitize that, which is going to be the next session on the 3rd of September, where we're going to talk about digitization of paper logs into creating a data set. Second, using, inventing and developing an AI model, and a bunch of other sort of choices we made. How we use that with supercomputers and GPUs that were available at our disposal. That's a totally different sort of discussion. So logs, when you hear Shivam saying logs, it's well logs, wells as in oil and gas for exploration. And these logs are all data, seismic data that go into very different features of understanding, looking at fractures, resistivity, and many other interesting features that are very, very specific to physics experts and people who are into the energy space. So just wanted to clarify that. Go ahead, Shivam.
I have a question.
Sure.
Sorry, I have my class starting. So when will it end?
So okay, I believe you have to leave. Is that your question? And you want to make sure when can you be available for the next session?
No, my question is when will this session end so that I can attend my class? My class is starting at 1.
All right, so the session is going to be recorded. So Professor Veerasamy is recording all this for you. So you can always go back and, once the recording is ready, he's going to make it available, and you can continue watching this from this point onwards. Does this answer your question?
Yes, thank you.
No worries. Wonderful. Go ahead, Shivam, with the demo.
Yeah, cool. So basically, giving you the brief, this login process is also done using the Firebase authentication system. So now let's see the demo part.
I love the music. It's a happy music.
Thank you, Terry.
So all these little nifty features of, when you're visualizing it, you can also scroll up and down easily. Those are making user experience only easier, because, a log file could be, pretty long sheets, the old fashioned printing paper, if you remember. that laser printer that keeps sort of, it's almost like stacking it up in a box. So those are the kind of little interesting visualization features that were also built into this application. And this is the actual data, which you can download as a CSV. And then you have your post-process log.
Yeah.
Which now is available for you for interpretation. Awesome.
Awesome. Cool. So wrapping up the thing, although getting this basic application was not an easy task. So the problems that we had, like we started developing the application and testing it on our home servers, in-house servers. But when we tried and tested, basically the efficiency of application was not that what we expected, because getting the models run efficiently and returning the results so quickly is not that you get on in-house servers. So we decided to move it to the cloud and created the MLOPs pipeline that Suhas talked about. So all the APIs and the microservices are running on the AWS clouds, and we are using the Firestore service to interact with that. And yeah, basically the front end is on React.js. That is like the somehow sums up about our application on the front end basis.
Perfect.
I hope, yeah, cool.
Thank you, Shivam. This is wonderful. There's a lot of effort that goes into building this app, and obviously the app is, when you see the dashboard, it's the beginning of how we were going to be adding more features into the app as you start adding the more of the customer requests, going deeper into the business model and trying to expose all the other challenges that customers have, and how to digitize, automate, and increasingly use machine learning to actually make lives easier for our customers. And in this case, Fred, he was a CEO and running this wonderful startup. Let me just, if you have any questions, do please post in the in the questionnaire here. I am going to now hand over to David very quickly. He's going to spend again a handful of minutes, but still explain to you another wonderful journey in which Shivam was again also involved. But I want David, who's very close to you. David Allen is at UTD Dallas, and has been working with us for quite a while also. He was actually our very first student who had passed from our live AI. So that was actually awesome. So the very first, we ran a beta program with UTD Dallas, thanks to Professor Veerasamy, and David happened to be sprinting his way all the way through our extremely, let's say, complicated essentials, AI essentials program. And we were so excited about David's performance in the Live AI course that we pulled David in as an intern. Since then, David has elevated into some interesting roles and is doing some awesome software development work. But it's obviously good to hear from you, David, because you're close to home. I know everything about you, but I shouldn't be talking about how you live, all the stuff that you're doing. Software development is a passion, but tell people who you are.
Okay, thank you, Terry. As Terry said, yeah, my name is David Allen, and I am a student here at UTD, undergraduate in the CS department, so you might see me on campus. But yes, I've been working with deepkapha for about a year now, and I've been specifically doing a lot of work with Live AI, which is our educational startup, so under the umbrella of deepkapha, which is offering educational courses online for ML, AI, deep learning. And one of the problems that we were facing as we were working with Live AI is it costs a lot of resources and time to manually grade assignments. So a coworker and I started developing a solution to this problem with an auto grader application. And I can show you. It started just as a prototype built in Flask. Let me see here. I'm going to share my screen. Can you see my screen?
Yep. I can at least.
Okay. Well, so as we're developing LiveGrader, which is an app that allows students and the teacher of the course to interact, submit assignments, and grade the assignments. Our prototype was, as you can see, very primitive, basic, but as we were developing it, we realized this could become something that we could integrate, we could turn into a product. And so my coworker and I, as we were building this app, my coworker would do the research into the API that does the auto grading, and I would develop the features in the code, push them onto Git, which he would then test on the server, and we'd go back and forth fixing bugs and such. But once the project started getting traction, we got more people on the development team like Shivam, and we migrated it to a whole nother framework, which involved having to refactor all the codes, make all the codes much more arbitrary. Like, for example, in the prototype, we had 5 assignments or so for the different weeks of the course, but in our new app, we need to make an arbitrary number of assignments available for grading. And yeah, so as you can see, this is a login page for the student side, yeah, as we were developing the app, each feature, as you can see here, we had several features. In the original prototype, every form, every single process feature was it could fit into one form and in one Python file. And now we had this whole new framework which had multiple files and multiple forms on a single page, as you can see here. For example, in this case, submitting an assignment and requesting resubmission. So there was a lot of work that we had to do finding solutions to these new problems that we were coming across as we started to expand or scale up this project. And eventually we split up the project into 2 branches of, I would work on the student side, with these features, like as a student interacts with the course, submitting assignments and downloading them. And Shivam would work with the admin side of the course, which involved the integrating the AutoGrader API. And I can show off. This is obviously not a live demo, but the features that came in with grading students, adding courses, and all that. And yeah, and we're still working on it. Now we're coming up with the challenge of integrating our own database into, because the app we have right now, the API uses its own database to manage students, and as we're finding out working on this project, that's not going to be good enough for our needs in keeping track of students and courses and such. So we're going to be integrating our own database into the app, and then so we can deploy it on servers. So yeah, and meanwhile, we're in different time zones too. I'm in Central Time, and so coworkers are in Indian Standard Time. So communication, we're meeting either early mornings or evenings, and but throughout that all, we're able to make pushes to Git, collaborate on code, have meetings, and it's really cool to see that. So yeah, I think I could. That's how I mostly what I had to say. I can share Shivam's video for the admin side.
I think we can, I suggest in the interest of time, we've spent an hour and 15 minutes. I think this was, you've already given a wonderful sort of, the look under the hood, both for the student and the admin application. I don't know, Jay, maybe it's probably something we can test it out at the UTD as well. But I mean, let me just wrap it up. I think, thanks, David, wonderful. So, the interesting thing of these webinars that we are doing, the 3 webinars, obviously in this whole huge series of webinars with Professor Jay is doing for you guys, is what we wanted to demonstrate is the ability to actually function inside a startup. And a lot of people come with the misconception that my role is limited to being a software engineer, or I am a researcher, I don't understand the other part. And what we really tend to do with our teams within DeepKapha is software engineers know ML, and they should be able to read and even write a research paper if they must. And researchers on the other edge of the spectrum should understand that if you're building something, find a data set, prove your hypothesis, not just theoretically, through theorems and equations, but also through a data set which can be tested in the real world. So so what I do is I push from both edges and bringing these disciplines together. And as you can see, Shivam explained that he's sort of an ML engineer. He understands all the ML techniques. David went through himself through quite an extensive training program. And I'm sure, he's quite young, second year student, very, very fresh and has a huge future ahead of him. So when you're infusing yourself with these skill sets, you're actually preparing yourself for the future better than anyone I know. So, I mean, I spent 30 years in the industry, in academia, and doing startups 10 years ago, 12 years ago, learning from everything where I had to spend months and years to learn a couple of things. And I thought if I could compress those 30 years into just a handful of months or maybe a year or 2, I can create those superhumans, or at least I can try. And what you're seeing here is that all these, wonderful individuals are pretty young, your age, or much younger than you in college, and are probably 10 years ahead of me when I was their age. And that is fascinating to see. It's not kind of, sort of blowing my own horn. It is something I wanted to do, and facilitating together with great partners at UT Dallas with Professor Veerasamy already sort of helps me understand that, well, there's validation. There are other people in the industry and academia who also realize the need. And we're super excited to actually share with you. So this was the software engineering MLOps perspective. So we showed you MLOps, and then we showed you software development from 2 different perspectives and 2 different startups. The startup which Fred has, Black Arrow Partners, is also developing sort of this dashboard. You've got a sneak peek into that dashboard from Shivam. If you have any questions, I see that most of you had to run to your classes. I guess I'm not sure if I'm pulling the rest of you guys also a little bit too long, and my apologies for that. I hope you had a good, you got some interesting experiences from the hands-on learning that we are doing on a daily basis in our startups within our DeepKapha family. And if you have any questions within UT Dallas, go reach out to David. He's going to tell you about a lot of things, what we do, how we work, how we collaborate, how we make sure that people are able to do things faster. And so that gives you a bit of a perspective. Yeah, Fred is here as well. We'll be meeting you again on the 3rd of September, where we're going to go deeper into the AI. So building models, training models, using all kinds of interesting techniques, computer vision, and data extraction, data manipulation techniques, and that's a fascinating sort of project as well. All part of Black Arrow Partners, the startup in Texas. So we are super excited to have sort of shared these experiences with you. Thank you once again. Thanks, David. Thanks, Shivam and Suhas had to leave. But I thank you all for this wonderful conversation. Reach out to David. He just shared his email address, or look into, I guess if you're using Blackboard, you can find each other already internally. And I hope to see you guys, and we're looking forward to, I was happy to hear that the college is still running in UTD Dallas and folks are going to campus. And I hope to see you guys physically soon as well. If not, on 3rd of September, we'll be back with the next webinar. Thanks again, guys, and we'll see you again soon.
Thank you, David. Thank you. Amazing. Yeah.
Thanks, everybody. Signing
Thank
off
you.
now. Take care. Ciao, ciao, guys. Bye-bye.